So let's just start with the Nexus VPC and what is that, why we use VPC, and what is the main feature of the VPC. So we are going to discuss those things. Okay. So VPC is a stands for Virtual Port Channel. Okay. Now, if I'm talk about the VPC, so VPC is a virtualization technology which is launched in 2019. 2019 2009 basically, which allows links that are physically connected to the two different Cisco Nexus series devices to appear a single port channel to a third endpoint. Okay, that means basically we use this VPC to connect the two different Cisco Nexus series switches together. Okay, the endpoint can be switch, server, can be router, or can be other device such as firewall or the load balancer can be also happen. That support the link aggregation technologies like the Ether channel, VSS, right? Layer 2 port channel, layer 3 port channel. So it supports these kind of things that inside of it. It also provide fast convergence upon link device failure or the link failure, if the link failure will be happen or any device failure will be happen. So it also provide the very fast redundancy in that. Okay, so before if I'm talking about the before technologies which is we were using, so we were using with the spanning tree protocol, and we were merging this both the switches together using this kind of link that would be your VSS or ether channel. But nowadays this is not compatible with your Cisco Nexus operating system devices. So then it launched the VPC to connect the multiple physical devices into the one logical devices. So they are connected with that, and the VPC peer link is going to, is going to basically bundle. That is, we called it VPC peering combination. Okay. So after that, what is VPC peering configuration, which is we have, so the Cisco Nexus 7000 and 7700 in a same VPC construct supported because of what? For the configuration of port channel, uh, the device number should be same. Sorry, the device port should be same. Duplex must match, right? And what are the criteria which is we have to bundle the particular port over here? All the same criteria which is we followed in the ether channel, same criteria we also follow during the VPC as well. So inside the VPC there will be the two things is gonna be work, that is primary and secondary. Okay, so once the primary will goes down, then secondary will take place, and then it will start sending the data towards their neighbor and all. Okay, so this is Cisco Nexus 7000 over here, one device is there, and 7700 is there. And let's suppose this is some Cisco devices of the Catalyst series of the switches. So we just configure the VPC between the VPC primary and the secondary Nexus series of the switch. Okay, and then we just convert into the one peer link, and then they are connected together as a one, right? So they are just understanding that we are just only one, right? They are understanding that we are just only one in that. But how exactly this one can understand, this is understanding that we also make a port channel, and we also form a port channel as a one. But exactly this is happening with this kind of VPC, or we can use the VSS over here, virtual switch system, right? So what will happen? This is our Cisco 7000, and this is our 7700 Nexus series. They are just binded together using your peer link. What? VPC peer link. But we do have the another port as well, another switch as well. Let's suppose switch 3, and this is also having VSS because of its support VSS only. So we can also configure the VSS on this Nexus series of the switches. Now let's do the some differences between VSS and VPCs. That is, what are the like functions which is they will get. So the VSS and VPC both support multi-chassis port channel, both support loop-free technologies, and they are also support spanning tree as uh, fail fail-safe protocols. Correct? So they are support both the protocols will support these kind of things. No destructive ISSU support. The VSS doesn't support that, but the VSS VPC does support this kind of things. Control plane. So the VSS having only single control plane logical node, which is we have, and VSS have the two different two independence active node. Like if my primary VPC goes down, then the secondary will take place over there. Okay. Now layer 3 port channel the VSS does support, but VPC have the some limited port channel for that. Okay. Like if you want to assign the things for the port channel, so this VPC does have sorry, the VPC might be can supported just the few protocols in that, or might be it supported the few um, the few information about the particular port as well. Okay, then it also having the configuration. The VSS have the common configuration, but the VPC have the two different configuration, which is for the primary and secondary VSS. Okay, ether channel have the static ether channel you can form in the VSS as a static VSS, PAGP and LACP, right? But the VPC does only support the two things, that is static and LACP. Okay, so after that, if I talk about what is the primary, how it works, and how what is a secondary, and what is a VPC port channel. So basically, this is our VPC peer. Okay, which is ready to uh, which is ready to make the port channel between the VPC domain. Okay, so this is the VPC peer keep alive link is going to generate over here. But when it will created, once your VPC peer link will be created, right? So like if your once VPC peer link goes down, then you have the another option that it can go through that, which is VPC peer keep alive link. So what is that VPC peer keep alive link? It is monitor the variety of VPC peer. Let me just make it a bit of zoom. Okay, now what is VPC peer first? Because of we know that this is our VPC peer. So a VPC peer switch one of a pair, right? That means there will be only one pair of the VPC switches. Then we have VPC member port. Okay. So what is the VPC member port? Interfaces that's belong to the VPCs. Okay. That is the interface is a kind of interface which is belongs to the VPC over here. Okay. Now then we have a particular VPC. So what is the VPC? The combination port channel between the VPC peers and the downstream devices. Okay. That is this VPC peer link. Okay. So whatever the physical connectivity between the VPC peer we have, they just bind it using your uh, any kind of VPC peer, and they just bind it together using your it called it once it will bind it together, then it called as a VPC peer link. Okay, so once your VPC peer link goes down, once your VPC peer link goes down, then the VPC peer keep alive link will work over there, and then it will start monitoring the particular VPC peer traffic over here. So what is that? What is VPC peer link? That is the link which is used to synchronize state between VPC peer devices and must be 10 gigabyte Ethernet port over here. Also, it can carry the multicast, broadcast, and flooding traffic and data traffic in case of VPC member port failure. Okay, so if any VPC member port will be goes filled, okay, so what will happen? How then traffic will goes it out? They have they can reach over here by this way. Okay, they can reach over here by this way. So they have the connectivity always they have. So that is the main use of VPC peer link. Okay, because of VPC member port does only and only support the uh, the VPC port channel only. Okay, they are just only support VPC port channel. Not it cannot support VPC peer link and all. These switches are only support VPC port channel with that. Okay, then what is the VPC peer link, peer keep alive link over here? It monitors the availability of a VPC peer in that. Then we have FCS. Okay, so what is the FCS? The FCS is called CFS. CFS is called Cisco Fabric Service Protocol. It is used to use for a state synchronization and configuration validation between the VPC peer devices. Okay, so how the Cisco Fabric devices can be formed using CFS. Okay, so whenever your VPC peer will be there, or VPC there, once your two VPC peer is binded together, so how they are just binded using your CFS port. Okay, got the point. Now we do have the orphan port as well. So what is that? That is non-VPC member port. That means where your user is going to create. Okay. So in the data center devices, we called it as a orphan port. Okay. Now, what other VPC components which is we have?
What is orphan port? There? What is orphan port?
The orphan port is looks like your where your user are going to create it. Okay.
Normal port.
Yes, normal port. That can be the server. That can be your normal user. Okay. That is we called it orphan port. Okay, that means non-VPC member port.
Ajay, here doubt is there. So
Mhm.
how many keep alive members link can able to create?
See, using your Ether channel, simple. Because of how we can connect the two devices, Ether channel, we have to form the port channel. Then they are able to connect. Then we can, then the VPC this function will be enabled. But this feature you cannot enable inside your the Cisco Catalyst series of the switches. It just only have the Nexus series switches only. Okay. So what are the VPC components which is we have? We will also going to discuss in the next slide. Okay.
So regarding VPC member port also the same thing. So there's no limit.
No. See, the VPC member port, if you are talking about, the one member port is gonna be happen in the different Nexus series of the switch, and one port can be the different Nexus series of the switch. Okay. Now let me just give you the some introduction about the VPC component over here. What are that? So this is a common domain configuration across the two VPCs peer devices. Only one VPC domain ID peer devices is permitted, and make sure to configure the same ID on the devices belong to the same domain. The domain ID range goes from 1 to 1000. So what we have to do, VPC domain we have to define just like in a port channel, what we have to do, we have to configure the interface port channel, and then we have to configure the particular port channel, and then basically we have to configure the all the kind of things like the trunking encapsulation protocol on the particular port channel over there, right? But in the VPC we have the VPC domain, and it comes with the VPC peer link, and the nexus series which is we are going to bind using the VPC peer link, that is we called it VPC peer. Got the point? That means whatever the Cisco series of the switches we have, those switches we called it VPC peer. Okay, where we have the ports on that particular switch. Okay, now how we can bind it together using your VPC peer link. Okay, and if you have the different nexus series of the switch, so we can bind using a VPC port channel in that. If I'm talk about the components, the VPC components which is we have. So this is how you can configure the VPC domain. What are the requirement which is we need to do? VPC domain. We can give any domain, that is the range which is we have 1 to 1000, 1000, right? Then we have to define a peer switch. That is, this is what? This is our peer switch. Then we can give the priority as well. And then we have to define the peer keep alive destination. That is from, this is our source, this is our destination, and this is our source. Means we have to define that this is our destination and this is our source. So between the two devices we have the particular IP address. So where we are going to configure, we have to define the both IP addresses from the where we are going to bind it together. Like in a port channel, what we do, like simply we just uh, we just go on the particular interface, and we have to make the first of all uh, the trunk port, and then we have to enable the particular port channel protocol over there, like LSCP or PAGP, whatever you are using, right? But over here inside the VPC we have to define the VPC keep alive, and we have to define the particular IP address of the port from the both the side, the neighbor IP address and its local IP address as well. We have to define that. Okay, I do not have access of the Nexus, otherwise I will show you exactly how it works. But if you want to write down commands, so you can write it down. Let me make it zoom. This is your switch one. This is your switch two. Guys, just write it down the command. Done, everyone?
Permanent change, writing the device to.
Okay, just completed. Done, everyone? You can write it down later. Okay. So, so we can check the VPC role, like whenever you wanted to check the particular role of the VPC, so you can run a command show VPC role. So what will happen? What it will show you? What is the VPC role? That is that will show you that it's a primary or secondary, right? And then it will show you the particular base map, the system MAC address as well. Okay, so always lower MAC address will be prefer first, correct? System priority, local system MAC, local role priority, and the everything which is you will have. This kind of things will show you inside the VPC role. So whatever the role it defined, it will show you that over here. Okay. Then we have VPC components, right? So what is that? This is an adjacent device which is connected via the VPC peer link, right? This is connected with the VPC peer link, and a VPC setup consists of two Nexus devices. That would be your this device and this device in a pair. Okay, using your VPC peer link. So one acts as the primary, that is this one, another as a secondary, that is this one. Okay, so this is the VPC peer. Then we have what? Keep alive. Okay, so what is that? If I'm talk about the keep alive, so VPC Peer Keep Alive link provide a layer 3 part that is used a secondary test. What? It is used a secondary test in addition of VPC peer link in order to determine whether the removed peer is operating properly. In a particular, it helps the VPC switches to determine whether the peer link itself has a failed or whatever the VPC peer is down, right? So let's suppose if the VPC peer link goes down, so what will happen? In this case, VPC peer keep alive link will work over there, and VPC keep alive link can be carried over the OOB management over the network, right? Now, what else? There is no data or synchronization traffic is sent over the VPC peer keep alive link. Only IP address, UDP traffic, or you can say that UDP packets on a port number. This on indicate that is organizing switches is operating in the VPC, running the VPC. Okay, that means this is not able to handle the lots of synchronization traffic sent over the VPC peer keep alive link. Just it sends only the IP address information and UDP packets information between the two switches. Okay, the default timer are in an interval of 1 second. Wait a timer out of 5 seconds. So you can say that hello timer, it sends after every 1 second. Hold down timer, which is 2 seconds, and you can say that max age timer. So that is 5 seconds. Okay, that means after every 1 second they will share their messages together, right? If any link goes down, if any VPC peer link goes down, so it will wait for the 2 seconds, right? If any VPC peer link doesn't or anything did not share between that till turning on your VPC peer link, so what it will do, it will wait for the 5 second, right? And then it will turn it off. Then your VPC peer keep alive link. What? The VPC keep alive link will work over there. Got it? Then it will exchange the IP address information and UDP traffic over there. Okay, just to just for what? Just for to send their information, to exchange their information together. So might be if any link goes down, so they can just travel anything using your VPC peer keep alive link over here. Okay, that is the main use of VPC over here. Now, uh, so what are the VPC peer keep alive link consideration is it should not be carried over the peer link when using switch virtual interfaces over there. You must configure VPC keep alive link before the VPC peer link in order for VPC domain to come up, right? That means before configuring the VPC peer, your VPC keep alive link we have to configure first. And once you configure the VPC peer link, then your VPC domain will come up, right? Just like your the port channel. So what we have to do, we have to basically configure first of all these interfaces. We have to make it as a LSCP or PAGP. Then the port channel will come up. The port channel is your VPC domain, right? If my one port channel goes down, so we have the another port channel, which is we called it VPC peer keep alive link. That was for an example, just okay. Don't go for the words and all. Now, what is the third option? When building a VPC peer keep alive link, use the following in a descending order of preference. So SVI via to trunk, make sure that VLANs is pruned for the peer link or not. Like sometimes your the VLAN can be not advertised inside your what, inside your VLAN database table. So might be then it is not going to share any information together as well. Then we have management interface as well. There can be not there is no redundancy on that as well. Then we have dedicated link, right? So for the dedicated link, we can configure the port channel, and it is also better configuration which is we can manage over here. Okay, so if I'm talk about components, which is how you can configure the keep alive link, this is how you can configure the keep alive link between the two PCs. Okay, if you want to write it down, you can write it down. The model number which is we are using, that is 5020. Okay, just write it down these commands, and then we will discuss the next slide.
Very daunting.
Completed. So that was all about the VPC. Like we have very depth concept of that, which is we are not going to do inside of that. Okay, because of if you will get in that, so you will get distract from the topic and all. That is why we are not going to more distract. We are not going to distract you just for that. Okay, I'll share you this PDF so you can just go and you can just learn whatever you want. Okay, so if I'm talk about VPC role election process, like how the role, basically the role is very important over here, right? Like how the VPC Peer Link is gonna be selected, right? Just like in a spanning tree protocol, how the root bridge is going to elect, right? How your DP port is going to elect, root port is going to elect. So as like same as we do also have in the VPC role election process as well. So what are that? Let's discuss. So let's suppose after VPC Peer Keep Alive and Keep Alive link are up, role election process start, right? Whenever the link will turn on, then the selection process will start. It sticky bits are the same, right? If sticky bits are the same, then what will happen? It rolls that it will move to the next criteria. Either it have the two option, that is switch with a true bit become a primary, right? Because of primary and secondary switch election criteria is going to be happen after that. So there will be your end devices connected. So if they will not able to find any primary or any secondary option over here, so it can go for the roles. So if role priorities are the same, let's suppose how basically this can select the process once your priorities are same, right? Sorry, the priorities are different. Okay, if you have if you have anything's the same priority with the same priority, so what will happen? Then it dedicate VPC role based on MAC address. That means then it will go for the MAC address, the lower MAC address. So whatever the lower MAC address these devices have, then it will assign it over here. Okay, so this is how the role election criteria is going to be happen inside the VPC, right? Multiple things, like if it is not going to check the priorities, the priority can be same, right? We can also do modification in the priority according to our requirement, but the MAC address cannot be same. MAC address can be different, right? So behalf of these two, the election criteria of primary and secondary VPC, that the VPC is gonna be electing that. Okay. So lots of content we do also have, like dual active exclusive interfaces VLAN as well. We do also have multiple things inside of that. VPC Peer Link, BPDU guide. We can also enable the root port, Maxis timer. You can get it. Hello timer. You will also you can see inside that as well. Okay. Same as like it is the see the spanning tree protocol will always work anywhere, everywhere it will work. Okay, and it is also compatible with the FHRP and HSRP over here. Okay, so just forgot these things for now. This was just an introduction of the VPC, like how the VPC is gonna be work, what is VPC and all, right? I'll share you this PDF, so might be you will get the detailed information about the VPC, and I will also try to upload the videos as well regarding the VPC over there, over the Google Drive link. Okay, so I will share you that as well. Is there any doubt in the VPC as of now?
Then we can create VPC in 7K and 5K both.
Yes, see, for the 7K, 5K doesn't matter. But the main concern is the duplex must match it. The duplex must match, right? Speed must
Okay.
match, right? Whatever the, the ether channel propagation criteria which is we have, same criteria we also have to follow in that as well. Okay, like if you have the 10K series, 10 gigabyte per second of the speed interfaces from the one side. Let me make the diagram so might be then you can understand. So let's suppose this is our 5K and here is our 7K, and let's suppose here is our 9K. But there is one condition: every switches have the port which is they are going to use, that is 10 gig. What is that? They have 10 gig,
VPC.
right? So easily they are able to bind together using your VPC in that. Okay, because of they will find the what, the same bandwidth, same utilization, and same process over here. So then it will just consider as a VPC peer link. Okay, and you also know the configuration. That is how you can do that. Okay.
Okay. And
Yes.
okay, VDC we can create only on 7K. Correct.
Yes.
So suppose in 7K we have created many of the VDC. Okay. So we can create multiple VPC also.
Yeah, definitely we can create it because of on our 5K and 7K and 9K we do not have just the normal ports. We have the 48 port, 92 ports, right? We have
Yes.
multi-port ports, so we can bind it together as well. According to our requirement, we can take the access and we can utilize the speed of the particular interface as well. Okay. When most of the time, uh, we use VPC for the binding purpose of the 40 gig per second of the link speed. Okay, most of the time because of whenever you will see, so most of the time 40 gig per second link is common for the nowadays because of every data center devices have this kind of modules, and they are working on the same 40 gig per second of the speed as well. Okay, so they are just you can bind it together as well.
So Jay, that you told about this 40 gig. So those ports are of 40 gig, 40 G ports.
Yes.
Okay.
Okay. So, but the rule is for the VPC binding is the same as your Ether channel. Okay. Like how you can do that? Duplex, speed, all the things is gonna be matched. Then you can able to configure the VPC over there. Okay.
Okay.
Any doubt regarding VPC now? If you have, no doubt.